top of your note sheet, write SOHCAHTOA, because we're still going to use SOHCAHTOA today. Okay, so I'll write it up here. Okay, so we're still using SOHCAHTOA today. We're just applying those ratios to some word problems, okay, with a little bit more vocabulary as well. So, to make a field goal, a kicker must kick the football with enough force and at an appropriate angle of elevation to ensure that the ball will go through the goal post. This angle changes depending on the placement of the football from the goal post. So we can find that angle that a kicker must kick it through that goal post. Okay? That's kind of what this is saying. We can find that angle using SOHCAHTOA. We can find how far away the kicker will be if we're given the angle already, stuff like that. So before we get started here, we're going to talk about horizontal and vertical. So if you forgot, horizontal lines are this way. Vertical lines go up and down. Okay, so if it asks you to find the horizontal distance, that's that straight line left and right. If it asks you to find the vertical distance, that's that line going up and down. So an angle of elevation is the angle formed by a horizontal line and an observer's line of sight to an object above that horizontal line. Okay, so this angle is created, say if you have a person and they're looking up at an object. Okay, so I'm going to draw kind of a picture here for you. Okay, so if I have a person, and I know you're not supposed to look at the sun, but we're going to have the person looking at the sun. Okay, it's an object above that person's line of sight. So the horizontal that they're talking about comes straight off of that person's line of sight. So where their eyes would be. Okay, off of that person's line of sight. Now this person is looking up at the sun here. Okay, up to the top of that sun. So your angle of elevation would be this angle here that is formed between those two lines. So between that horizontal and where they're looking up to. That is your angle of elevation. Your angle of depression is the angle formed by a horizontal line and an observer's line of sight to an object below that horizontal line. Okay, so very similar as angle of elevation. Now we're just looking down at something. So say I have this person here standing up on a cliff or something. They're standing up onto something. And they're looking at this car down here. Okay, this is my car. It's fine. I don't know what's a car. Now, again, your horizontal line comes off of that person's line of sight, okay? Straight off that person's eyeballs. And then they're looking down at the car. Okay, so we're looking at that car. That angle formed between the horizontal and where they're looking is your angle of depression. Your angle of depression is not between the vertical and where they're looking. Okay, that's what trips a lot of people up in this part. So if it talks about an angle of depression, it's from that horizontal off of the person and where they're looking, not the vertical and where they're looking. Okay, does that make sense? All right, so all of your horizontal lines are parallel to each other. Okay, parallel meaning they're never going to intersect. So any horizontal line you have is going to be parallel to the next one. Now if you look over at that picture, I know it's kind of hard to see, but there's a person standing right here. And there's a person standing up here. Now if this person on the ground is looking up at that person on that cliff, their horizontal line off of their eyesight there is that dashed line. So your angle of elevation to that other person would be right here. Okay? From this person on this cliff, again, their horizontal line is dashed. And if they're looking below at that person, this is your angle of depression. Okay? Those two angles are going to be equal to each other. Okay, so if they give you an angle of elevation, you could also draw your picture where it is considered the angle of depression. Okay, if you make that rectangle. Okay, because you can see that this makes that rectangle there. Those two angles are equal or congruent. Okay, just something to keep in mind as we do go through and draw these pictures. It'll help you try and figure out those sides that are missing. Any questions before I go through the first example? All right, so example 1. When you have word problems, make sure you read through the problem and underline anything that you think will be important in that problem. So Leah wants to see a castle in an amusement park. She sights the top of the castle at an angle of elevation of 38 degrees.
How'd you pronounce that English?
Elevation?
Elevation?
Elevation.
Elevation? Like an elevator? Elevation?
She said elevation.
I'm kind of like stuffed up, so I'm sorry if you can't hear what I'm saying. She knows that the castle is 190 feet tall. Leah herself is 5.5 feet tall. And we want to find how far away from the castle she is to that nearest foot. Okay, so that's what we're looking for. My next step, I want to make a sketch or draw a picture. So I know I need a castle because that's what she is looking for. Now your castle doesn't even have to be anything elaborate. Okay, it could just be a line if you want it to be. But here's my castle. Okay, there's a door. Good enough. I know it's not a castle. It's fine. It's Rapunzel's castle. Okay, so our castle, we also have Leah standing away from that castle. Now we can put in our measurements. Well, this castle right here is 190 feet tall. So from the top to the bottom is 190 feet. Okay, we know that Leah is 5.5 feet tall. What does that make her in 5 foot? How many inches? Anybody? Anybody? 5'6". Good job. All right, so now we also have this angle of elevation. Okay, so the angle of elevation from Leah's line of sight, so her horizontal line off of her head, to the top of the castle. Okay, so she's looking at the top of the castle. Right? That's her line of sight to the top of the castle. Now that angle of elevation is formed by that horizontal there. Okay? So between that horizontal line and her line of sight, that angle is going to be at 38 degrees. Now, if you notice that horizontal, it doesn't hit the bottom of this castle here, right? It hits up here. So what would be the distance from this top part to where Leah's horizontal hits that castle? How would I find that? Good. You're going to take the castle's total height of 190 and you're going to subtract Leah's height from that. Okay, because Leah's height will hit that castle where that horizontal hits. So that height will be 184.5 feet. Okay, so here I want you to notice that you have a right triangle drawn in. Okay, so here, here, to here. Okay, so you can see that there's that right triangle that we made. Now, if it's too hard to read with all of the picture and everything, off to the side, you can sketch a new right triangle given the measurements you know now. So if I have that same right triangle here, it's not perfect, but it's fine. Here's my 90-degree angle. I know this angle is 38 degrees. And I know this side is 184.5 feet. Okay, now back up in my problem, we wanted to see how far away she is from the castle. We don't know how far away she is. That'll be your horizontal distance. Okay, so how far away she is will be that horizontal distance. So right here would be our x value. So in our smaller picture here, that side would be our x value. So I want to find one of my sides of a right triangle, so I'm going to use SOHCAHTOA. Going from this angle to the other side, that's my opposite side. And the side next to it, where I labeled X, is the adjacent side. So I have O and A, so I'm going to use tangent. Okay, so I have tangent of the angle I went from is 38. That's equal to, the opposite side is 184.5 over our adjacent side is X. Okay, then solving this, we want to multiply both sides by whatever's in the denominator so that it cancels out on the right-hand side. So we have X times the tangent of 38 equals 184.5. To get X by itself, we'll have to divide by tangent of 38. Those cancel. I can plug this into my calculator. And you should get X is equal to 236.15. Now, in my question here, it says to the nearest foot. So I can write she is 236 feet away. Okay, so that's your nearest foot. Any questions on how I set this problem up? All right, looking at the back. Example 2. Okay, at the circus, a person in the audience at ground level watches the high wire routine. A 5-foot, 6-inch tall acrobat is standing on a platform that is 25 feet off the ground. That's supposed to say ground, not round.
Did you take this?
Yeah, I forgot a G. How far is the audience member from the base of the platform? Okay, that's what we're looking for. If the angle of elevation from the audience member's line of sight to the top of the acrobat's head is 27 degrees. Okay, so next step is to draw our picture, make a sketch. So I know I have a platform. No, it's somebody rolling something down the hallway. Or an airplane. An airplane. Okay, we have a platform. We have our acrobat standing on that platform. Okay, we have an audience member at ground level. All right, so our acrobat is 5 foot 6 inches tall. So all of that in feet would be 5.5 feet. It's 5.5 feet. The platform is 25 feet off the ground. So from that top part there to the ground is 25 feet. Okay, so from the audience members' line of sight, so our horizontal is at ground level. Okay, up to the top of this acrobat's head. Okay, that angle of elevation is 27 degrees. And we want to find how far away that audience member is from the base of that platform. So that would be your horizontal there as your X value. All right, do you see the right triangle formed? Okay, this would be your right angle right here. This is our angle. Now, if I'm going from the top of the acrobat's head to the base of that platform, I need that entire distance together. Okay, what's that entire distance? 30.5 feet. Okay, and again, if you don't need to draw the triangle again, you don't have to. I do just so it's easier to look at. So I have my right triangle here. I know this angle is 27 degrees. I'm looking for this side, and this entire length to the left there is 30.5 feet. Okay, so now again I can use SOHCAHTOA to find that final side. Going from that angle across would be the opposite side, and the side next to is the adjacent side. So again, I'm going to use tangent. Okay, so I have tangent of 27, since that's the angle I went from, is equal to 30.5 over x. And again, I want to multiply both sides by whatever's in the denominator, so multiply by x. So we have x times the tangent of 27 is equal to 30.5. To get x by itself, we're going to divide both sides by tangent of 27. And I can plug then this into my calculator. And you should get x is equal to 59.06. Okay, so the audience member is 59.06 feet away. Okay, questions on how I set up example 2? It's okay to ask questions. So again, it's the same thing that we've been doing. You just have to kind of pick out the information and draw that picture first. All right, so last problem, example 3. We have a search and rescue team is airlifting people from the scene of a boating accident when they observe another person in need of help. If the angle of depression to this other person is 42 degrees, and the helicopter is 18 feet above the water, what is the horizontal distance from the rescuers to this person? So we're going to make a sketch. So we have a helicopter. Helicopter. We know they're taking them out of the water, so I'm going to draw some water in below here. And there is a person still in the water. Okay, person still in the water. Now we know the angle of depression to the person from the helicopter is 42 degrees. Now to create that angle, you need that horizontal distance off of whatever's looking down at something. Okay, so our horizontal comes off of that helicopter because they're the ones looking down. Okay, then we have them looking at this person in the water. Okay, that angle created by those two lines is your angle of depression, and that is 42 degrees. Okay, next I have the helicopter is 18 feet above the water. So from here to the water is 18 feet. Okay, and we want to find this horizontal distance from the helicopter to the person in the water. Now this is where I was trying to tell you your angle of elevation is equal to your angle of depression. Okay, because you have a picture like this where you could draw in a rectangle. Okay, so your opposite sides are the same. Or you could think, so the helicopter's angle of depression is 42, so that from that person's line of sight and their horizontal, their angle of elevation should also be 42. Okay, so this angle is the same as this angle. Otherwise, this side is the same as this side. Okay, and this x is the same as this horizontal distance. Okay, and I can make that right triangle there. So I'm going to redraw in this top right triangle down here just so it's easier to look at. Okay, here's the right angle. My horizontal is that x. My angle of depression was 42 degrees. And this side over here is 18 feet. Okay, so from that angle, going across is the opposite side. Side next to is the adjacent side. So yes, you're using tangent again. No, it's not always tangent in these problems. Okay, so these ones happen to be tangent, but it is not always tangent. Okay, so I have the tangent of 42 is equal to our opposite side 18 over adjacent x. Multiply both sides by x. So we have x times the tangent of 42 equals 18. Divide by tangent of 42. Plug into your calculator this right here. Okay, and we'll get x is equal to 19.99. Okay, or I could say about 20 feet away. Okay, any questions on these word problems?